Hi everyone, can people hear me? Oh, good. So I think we better get started. So first of all, welcome everyone to this panel. In this session, we'll be exploring agriculture research for food and nutrition security. So this event features passionate researchers from Crawford Fund, highlighting their work in agriculture in developing countries and Australia, and its impact for our neighbors and for them. So this panel includes Ms. Cathy Reade, Professor Lee Hickey, Dr. Dee Mayberry, and Dr. Tamara Jackson. Ms. Cathy Reade is the Director of Outreach and Manager of NextGen, Crawford Fund. Professor Lee Hickey is the Principal Researcher Fellow at the Centre for Crop Science, Queensland Alliance for Agriculture and Food Innovation at the University of Queensland. Dr. Dee Mayberry is the Senior Research Scientist and Team Leader in CSIRO Agriculture and Global Food Team. And Dr. Tamara Jackson is the Program Manager at ICRISAT Sustainable Development Invest Portfolio, who will explain the impact of research to improve food, energy, and water security. I'm thankful to you all for sparing your valuable time to share your experience through this panel. I will now hand over to you.
Oh, hi, great. Thank you very much. And hi, everyone. If there's a single message that we want to get over to you today, it's that agricultural research can deliver global, professional and personal impacts. We'll hear about research impacts from 3 researchers working in very different areas in agriculture. They'll share their experiences, explain the impact of their work, and if there's time, hopefully some tips about how to get involved in agriculture for food and nutrition security. We actually don't know who's out there or what you do. So we'd all really love to know more about you as well. So if you could introduce yourself and where you're coming from, for example, in the chat function, that'd be terrific and we can get some interaction happening there. Also, we'd welcome all your questions. We've got lots of different areas of research happening today. So if you could just enter your questions in the Q&A function, and then we'll work through all of those towards the end. I'm not an research impact specialist, possibly like a lot of you are, but I imagine that there's many ways to measure and study impact. There's also studies to measure the benefits of agricultural research projects. And in fact, the Crawford Fund has one underway at the moment. But I thought a few recent studies that may be of interest in the background of what we hear today. Much of Australia's support for international agricultural research is through the Australian Centre for International Agricultural Research. ACR's work aligns closely with Australia's Development Assistance Program, supporting research collaboration for improved livelihoods. They did a study on benefit to cost ratio of a suite of their own projects and found that on average, for every $1 spent on research and development, ACR projects delivered $102 in return. Some of you may also have heard of the international research centres that make up the CGIAR. A report late last year showed investments in their research generates a median return of 10 times the investment. But averages and medians and returns on investment and cost benefit ratios, all those things don't really tell the story of impact. So today we're going to hear from these 3 researchers doing different types of agriculture research with very different impacts, I expect. Impacts in the countries where they work, impacts to them personally, and impacts to Australia's agriculture as well. You'll just have to forgive me now as I read some short bios on each of them so you know where each of them is coming from. So Dr. Dee Mayberry is a Senior Research Scientist with CSIRO Ag and Food. She completed a Bachelor of Science with Honours in Agriculture at UWA, the University of Western Australia, for those that aren't from Australia, followed by a PhD in Ruminant Nutrition. She then spent 10 months volunteering in the Philippines before doing a postdoc at UQ and joining CSIRO in 2013. Dee is a founding member and former Vice President of the Researchers in Agriculture for International Development Network, which I'd love you all to write down. I'll put a little tag of it in the chat function later. So Reade is a lot like the RDI network, which is the organisation organising today, but it's sort of focused on agriculture. She was also a former Crawford Fund scholar or conference scholar. In her current role, Di combines her background in ruminant nutrition with systems modelling to improve the long-term viability of livestock production systems in Australia and in developing countries. Her research portfolio encompasses work at the animal, the farm, the household and regional scales. And she's worked on sheep, beef and dairy production in Australia, Indonesia, China, Myanmar, India and Tanzania. Pretty good cross-section there. Dr. Lee Hickey is a Principal Research Fellow at Cathy, which you heard earlier on from UQ. Lee is a member of our Queensland Committee and was also a former Crawford Fund Conference Scholar. Lee leads a team conducting discovery and applied research on the important cereal crops, wheat and barley. That includes understanding the genetics of key traits like drought adaptation and disease resistance, plus the development of novel technologies to assist plant breeders. He has a strong interest in the integration of leading edge breeding technologies, such as his speed breeding, which I'm sure you'll hear about, with genomic selection and genome editing. His advice for speed breeding crops is sought internationally, and the technology is now adopted by programs worldwide, fast-tracking the development of improved crop varieties globally for farmers. And Dr. Tamara Jackson has worked in South and Southeast Asia for the past decade, projects funded by the Australian Centre for International Agricultural Research, which I mentioned earlier. She's worked on farming systems projects spanning a range of goals from improving farming and marketing systems, building capacity in systems thinking, stakeholder engagement for communication and collaboration. Her current role is the Program Manager for the Sustainable Development Investment Portfolio, which aims to maximise agriculture's contribution to sustainable food systems in the Eastern Gangetic Plains of Bangladesh, India and Nepal for improved food, energy and water security. She has postgrad qualifications in applied hydrology and research management, and a PhD research explored water use efficiency, energy consumption and greenhouse gas emission relationships for different irrigation systems. All of those things for the three speakers really are right at the top of the world's discussion and consideration of food systems at the moment. So I'm really looking forward to hearing from them, and I'll now hand over to Di.
Thanks, Cathy. Morning, everyone, or afternoon, depending on where you are in Australia and the world. It's great to see a couple of familiar faces and names popping up in the chat. I wanted to start this afternoon by providing you with a little bit of background about my career, if I can get the slides to change. Cathy's covered a little bit of this in the quick bio already. But I grew up in a small town in regional WA, but I've spent most of my adult life in the city. So I definitely consider myself a city kid rather than a country kid. I did a degree in ag science straight out of high school and then moved straight into doing a PhD on sheep nutrition. And the application of my PhD research was really quite specific to WA production systems. So after I finished, I ended up with a job in the local ag department. But like many people, I was keen to see more of the world, and I felt I needed a bit of a break after 8 straight years at university. And so I signed up for a year as a volunteer in the Philippines through an Australian government volunteer program. And the project that I worked on was about vegetable production, which taught me 2 important things. The first is how much I really love working with animals. And the second was that Australian science and agricultural research in particular can make a huge contribution to global problems like food security and addressing climate change. So at the end of 2009, I came back to Australia and did a postdoc with UQ. And then after finishing at UQ, I moved across to CSIRO, where I now work on a range of projects both in Australia and overseas. One of the best things about my job is that I get to work with researchers and livestock producers all over the world. Before COVID, I used to travel a lot, like 10 trips a year overseas for fieldwork and for meetings. And a lot of my friends and family think this sounds pretty glamorous, but the reality is that you spend your days in airports and meeting rooms without windows, and you miss out on a lot of the important things back home. But the best trips are the ones with fieldwork. Absolutely nothing beats walking around a paddock, kicking the dirt, talking to farmers, or walking alongside a local research team to get stuff done. You meet people and you see places that you never would get exposed to as a tourist. Unfortunately, COVID makes that impossible at the moment, and so everything has to be done remotely. So instead of airplanes, I spend lots of hours on Zoom. And I currently work on projects with colleagues all over the world. The reality of working in Australia when you work with the US and the UK is that you end up dialing into workshops that start at 11 p.m. in the evening. But the reason I do this job is because I'm super passionate about livestock. Livestock are an important source of income and nourishment for millions, if not billions, of people around the world. And they make a particularly important contribution to the nutrition and livelihoods of women and smallholder farming families in low and middle income countries. They're also a source of draft power, transport, social status, savings, fibre, milk, leather, fuel, so many things. And in Australia, the production of livestock, particularly ruminants like sheep and cattle, as well as providing employment for large numbers of people, is the biggest use of land around the country. And ruminant livestock production also helps farmers to diversify their income and manage risk. And it's often the only economic land use in marginal areas where it's not profitable or even possible to grow crops. But as many of you know, livestock are also a source of greenhouse gas emissions, and there's increasing pressure from governments and consumers to reduce the environmental impacts of production. So I'm pretty proud that research that I've contributed to has helped play a role in defining the red meat industry's goal to become carbon neutral, or at least make substantial reductions in greenhouse gas emissions. So broadly, the focus of my research is pulling together different ways to help improve the sustainability of livestock production systems in Australia and overseas, to improve the livelihoods of farming families and to decrease the impacts of livestock production on the environment. And that involves finding ways to make systems more resilient to the impacts of climate change and other challenges, and improving the efficiency of production through changes to land and animal management. And I work on a range of projects funded by industry, by government, by international donors. And we collaborate with a range of stakeholders from farmers and extension staff through to academics and policymakers. But one of the challenges of working across multiple countries is the huge variation in production systems. So a smallholder farmer in Indonesia, if you look at the photo on the left, they might keep 2 to 3 head of cattle. They'll be in a pen in the backyard or even the back room of their house, and all their feed is cut by hand and brought to the animals every day. In comparison, a farmer in North Queensland might have 2,000 to 3,000 cattle, and they're left to graze freely on native pastures and mustered twice a year, where they're brought in for husbandry procedures or for sale. But the broad challenges and the underlying science are the same. So both systems are aiming to produce calves, which are then grown out until they're big enough for sale. So to improve efficiency in both systems, we need to increase reproduction and growth rates by addressing nutrition, mating management, and disease. To decrease methane emissions, technologies like feed additives or new animal genetics or vaccines, they can be used in both systems, but the challenge is in working out how to implement these changes in a way that's cost effective and practical for farmers. The impacts from the research projects we work on can vary and can include capacity building of the teams that we work with overseas, or changes to the way farmers manage their land and animals. Building capacity is really important, and it's one of the most rewarding parts of what I do, because we're setting up other researchers and institutions to have much bigger impacts in the future. In terms of impact at the farm scale, I think it's really important to highlight that impact can happen at multiple scales. So a lot of research, especially things I've been involved in early in my career, focuses on the animal or the farm level. And this is where individual farmers have control and make decisions. But there are also impacts that can be achieved at the landscape or the region or the national scale, where much larger groups of people are making changes to how they farm. And these broader changes often happen in response to changes in policy or government programs. In terms of research, it's really important to consider, I guess, the specific stakeholders that you've got in mind when you're designing a research project and understanding what their challenges and their drivers are. Which brings me to the final point I wanted to make, which is that which is the importance of developing and maintaining good relationships and talking to people about what's important to them. So good relationships with farmers, funders, and other researchers are essential to understand the challenges and opportunities and to help plan effective research. They make it possible to achieve project goals, create long-term change, and also make the process a lot more rewarding. The best relationships I have in my career have been built by working together and often through shared meals or experiences, whether those experiences are good or bad. We work long days and there's a lot that you can learn about your colleagues in the 8-hour drive between Yangon and Naypyidaw. You bond over crappy toilets, digestive upsets, bed bugs, and sweating your way through long days of fieldwork in hot and humid conditions. But at the end of the day, you get to sit down and share a meal or a cold drink, and you learn about other people's cultures and traditions. And it's definitely one of the most rewarding parts about what we do. So to finish up, I'm just going to finish with a few key points that might be useful for anyone else considering a career in agriculture. Everyone's pathway is different. You don't need to come from a farming background, and there are a bunch of different ways that you can get involved. Agriculture is so important. Many scientists work both in Australia and overseas, and sometimes it seems like more work, but working across different production systems and cultures helps to develop a more holistic overview of how things fit together. And I'd argue it makes you a better scientist and probably a better person. Every country is different, but the basics of biology, physics, economics, whatever it is you're interested in, don't change. So work out what you're good at and passionate about and focus on that. Engage with producers, ask the dumb questions and be prepared to change how you view the world. Create and maintain networks, both with senior researchers and other people that you can learn from, but also other students who will be your future work colleagues. And finally, take opportunities where you see them. I know that personal relationships, finances, family responsibilities, and at the moment COVID, make it really difficult to pick up and move across the other side of the world. But there are lots of ways to get involved in a rewarding career in agriculture. And with that, I'm going to stop sharing my screen and pass to Lee. Thanks.
Thanks a lot, Di, for a great talk. And some really great examples on how you're having some great impact in animal science in a lot of developing countries. I guess I'll focus on some of the work that we're doing in crops and specifically around some of the crop breeding technology and how we're working with partners around the world to set up this sort of technology to speed up the development of more productive and resilient crops for our future. We face a pretty big challenge in terms of feeding the world. There's estimated to be about 10 billion people by the year 2050. This, together with our climate really changing, presents some pretty big problems around how we produce food. And this figure here just summarizes the situation for wheat at a global scale. So the yellow line is the trend line, where we're going in terms of wheat productivity. And you can see this is insufficient to meet the demand for the future. The green line is where we need to be. So we really need to increase the rate of genetic improvement in a lot of our crop breeding programs around the world. So crops like wheat, barley, maize, sorghum, these sorts of crops. And the way we're going to get there is by improving the genetics in these crops for heat tolerance, drought tolerance, etc., but also packaging that genetics with better on-farm management practices, so agronomy there. And so this brings me to a tool that can help with the genetics side of things. It's called speed breeding technology, developed at the University of Queensland over a number of years. You're looking at one of the facilities that we use to speed breed crops all year round, growing up to 6 generations per year for all of our research and breeding applications, essentially controlling light and temperature to initiate early flowering of these crops and thereby grow a very fast crop for these different species. This whole idea of speed breeding technology actually was inspired by NASA-funded research back in the 80s. And they were aiming to grow wheat in space. And the way they were doing it was exposing the plants to continuous light, so the plants didn't sleep. It tricks them into flowering much earlier than normal, and so you could grow a really fast crop. My colleagues here at UQ thought this was a great idea and could really help with our research and breeding efforts on Earth, and so started testing this technique back in 2003. And so over the years, we've been slowly refining the technique and adapting it to different crop species that are really important. Here, in a nutshell, you can see what's involved and what can be achieved. So for the crop wheat, we can grow 6 generations per year using speed breeding, where we grow the plants under 22 hours of light. We're nice to the plants. We give them 2 hours of dark. And so this is essentially the protocol compared to regular glasshouse control, where you have less control of the conditions. You can grow between 2 and 3 generations per year. And this is really important from a plant breeding perspective because there's many plant generations that need to be grown in order to combine the right genetics for the ultimate crop that a farmer can grow. When we first actually started to spread the word on speed breeding, a lot of people just didn't believe us, didn't believe how fast these plants grow. So we captured a time lapse in collaboration with our partners at the Earlham Institute. You can see here wheat growing under speed breeding conditions on the left versus a regular glasshouse on the right, because seeing is believing, right? And there you have it. Wheat growing under speed breeding has already flowered and is now starting to mature, filling the grain, and it's ready for harvest. Unfortunately, we don't have time to finish the video for the normal breeding conditions there, far too slow. And as it turns out, this technique we originally developed for wheat works for a whole bunch of important crops that are, we like to refer to them as day neutral and long day species, where this long photoperiod promotes or triggers flowering. So you can see these pictures are a great example of the growth rate differences that we see when we plant them at the same time under speed breeding on the left versus irregular conditions on the right. And as researchers around the world start to trial this technique for their favorite crop, the list is growing. And so we teamed up with a bunch of researchers around the world from the UK, other partners here in Australia, and we published a step-by-step guide as to how to actually implement speed breeding, because the reality was that there wasn't much information available how you actually go and set up facilities and implement this for different scales. So we're doing about small scale for research to really large facilities like the one you're viewing now in the John Innes Centre in the UK. And so you can imagine, because this technology involves a lot of energy to power the lighting systems and cool the environment, to control the conditions just right for rapidly turning over the generations of crops, it's pretty problematic to deliver this type of technology in remote locations or perhaps developing countries where this tool could be useful for crop breeding. And so we started to think out of the box. What could we do? And so this is one of the ideas, to deploy speed breeding in a capsule sort of mode, which is essentially a modified shipping container fitted out with solar panels on the roof to help supplement energy costs or rely on the grid source. So the great thing about this tool is that it really is flexible. It can be delivered and implemented in totally different ways, depending on the crop and the resources available. Some of the things we're doing is also running workshops on speed breeding technology. This was some footage of a workshop we ran in Kenya, where participants actually built their own desktop speed breeding cabinets. And you can see here, this cabinet's running on a Raspberry Pi device where you program in the optimal conditions for your crop to get it to flower quickly. And while this desktop cabinet is really not big enough for their big crop breeding programs, it was really critical for the participants to learn what are the key elements that they need to control to implement speed breeding on a bigger scale to support their programs. I've been having a lot of fun working with ICRISAT over the last couple of years as part of their project called Avisa, which is funded by the Bill and Melinda Gates Foundation. And the main goal of this project, from my perspective, is around establishing centralized facilities to implement speed breeding for some of their important crops. And they breed crops that are really important for Asia and Africa. So smallholder farmers are growing these types of crops like sorghum, millets, groundnut, chickpea, and pigeon pea. And while I've been learning a lot working on these species, we've also been developing the speed breeding protocols for these crops. And as you can see here, this is our favorite protocol, which is a work in progress. But at the moment, using this protocol, we can grow 4 generations of sorghum per year and 5 for pearl millet. So these are tropical short day species, and you can see the protocol is very different to the wheat protocol. So 10 hours of light per day only to promote early flowering in these species and very warm temperatures. And as I said, a key part of this project has been around developing the facilities for them to actually implement this as part of their breeding operations. And we're partnered up with some people from Corteva. So this is a public-private sort of partnership as well. And they've contributed some really valuable information around facility designs. And so you can see here, we're just sitting out the front of one of the facilities while it was under construction there at ICRISAT in India. Their campus is just located outside of Hyderabad. But this is where a lot of the crop breeding happens from many parts of Asia and Africa. And here, just to give you an idea what they look like. So this was a situation where we had existing glasshouse infrastructure, and we've simply just fitted this out with the latest LED lighting technology, automatic irrigation systems, and upgraded the air conditioning systems. And this room is suitable for growing chickpea all year round, 6 generations a year. And here you can see we're about to walk into this room suitable for speed breeding sorghum and pearl millet. And you can see the blackout curtains are drawn, which is really important for imposing those short days, which are essential to rapidly cycle those crops. And in this room, they can grow up to 40,000 inbreds in just 1 year. So getting through those many generations much faster than normal than growing them outside. You can really only grow 1 or 2 generations per year. So how does this tool have impact in the plant breeding programs? Well, just to give you an idea, this is an overview of a traditional plant breeding program, the different phases involved. So generally what happens is you have a crossing and inbreeding phase, so crossing the best varieties with the other best ones to mix up the different traits. You then have a testing phase where you test those derived materials or progeny across many locations for yield and quality and other traits. And then once the winner has been identified, seed is bulked up and made available to the farmer. And this is what happens when we introduce speed breeding into the equation, into these programs. We can really shrink down this crossing and inbreeding phase. And so this means that the breeding cycle can be really condensed down. The rate of genetic improvement can be accelerated over time. And ultimately what this means is a much shorter pathway to developing these more resilient and productive crops that we need. Of course, our science and research can have a big impact in breeding programs, and that's fantastic, but there are also many other reasons to be involved in international ag. And like as Di said, you know, one of the perks of the jobs is really travel and experiencing all the many different cultures. And I get to work with really smart people around the world and taste all these different delicious foods. So it's really an amazing job, and very lucky to be involved and collaborating with people around the world. Thank you very much. I'll now hand over to Tamara.
Thanks, Lee, and thanks, Lee and Di, both for your presentations. They were fascinating. Just let me get my PowerPoint slide up. See that, and is it on full screen? Cathy, can you see that?
No, sorry, I can't see it.
Says I'm screen sharing. Sorry. Let me try again. Hang on a minute.
So just while Tamara's doing that, we're hoping to get lots of questions from all you people listening and watching. So if you can post your questions in the Q&A, that'd be terrific. Otherwise, we'll have to wrap it on.
Sorry, it says I'm screen sharing, but oh, hang on. Can you see that now?
Unfortunately not.
Okay, just wait a minute and see if it comes up. Okay.
Wouldn't be an online event without problems with PowerPoints, I don't think. Are you there, Tamara? I think you've frozen, so possibly that's why we're having trouble. While Tamara might need to go in and out again, perhaps. Just getting some messages here. Sorry, everybody that's listening and watching. Okay. Oh, here she is. She's back, coming back in. Sorry, everyone. Okay.
This is kind of a good example of what happens kind of on the regular with things not quite working and having.
Yeah, this is like being somewhere else, isn't it?
Exactly right. Let
me
try
again.
Try and share. I'm really sorry, everyone. Hang on a minute.
They're just there is some suggestions in the chat, Tamara, as well. Ah, there we go.
Have you got it now?
Yes, we do.
Okay, excellent. So I've tried to make it full screen. Have you got? Yeah. Okay, yeah. Good. Sorry for the technical hitch, everyone. So as Cathy has introduced, I'm Tamara Jackson, and I wanted to share a little bit about my experiences in AR4D and give some examples, different examples to Di and Lee of research that's focused on improved food, energy and water management. So I guess a little bit about my journey so far. I actually started out doing a teaching degree, and then after that was a false start. I quit that and started worked in horticulture and travelled for a few years before I went back to uni, and like Di, just went and did ag science honours and a PhD all in a row. And during that time, I did take every opportunity I could to travel, and I spent time in Myanmar and Pakistan. And I went to any other kind of conference, did summer studentships, basically anything I could to kind of experience other things. And during that time, my work was study was focused on irrigation and water management. So after I finished my PhD and I took an extra year of parental leave, I got a job with CSU based in Laos, where I moved to the south of the country for a couple of years with my husband and my then one-year-old son. And we thought we were going for a couple of years. We ended up spending most of the next 7 years in Laos, where I worked on projects that covered farming systems, extension, multi-stakeholder approaches, and the vegetable sector. So in short, not much of what I'd actually studied at uni. After that, I moved to Nepal to work in my current role as the program manager for ACR's Sustainable Development Investment Portfolio, which is a broader portfolio funded by DFAT. And that program works in the Eastern Gangetic Plains of Bangladesh, India, and Nepal. So I think, when I condense my kind of career neatly, it sounds impeccably managed. But in reality, it's been a series of kind of doing things that different projects needed and filling gaps, saying yes to lots of different opportunities, most with fairly unclear boundaries when I started them, but always, having the drive to work in agriculture and development. And I would like to point out that all of the things I included in that little kind of career thing were specifically in there. So I think it's important to acknowledge, the very diverse experiences that we all have, but mine has been, yes, moving, living internationally, and my family have come along for the ride. So before I talk about the impacts of research, I wanted to just make a note about the importance of partnerships. I think this work is all about partnerships. The program I work on has 20 projects of different sizes and over 40 partner organisations. And I'd like to acknowledge that the research results I'm presenting are the partners' work. It's not my direct research. So I wanted to explain or give some examples of the impact of research to improve food, energy, and water security at some different levels. So, the impact of the work for farmers, the impacts of the work for kind of development and in the Eastern Gangetic Plains, and then impacts for Australia. So in terms of the farm level, there have been a few projects in ACR SDIP that have worked to facilitate technical and institutional change to support scaling of more sustainable and climate resilient farming systems in the Eastern Gangetic Plains. So those farming systems are based on conservation agriculture for sustainable intensification, what we call Cathy. And at the farm level, these practices, when used by farmers in the Eastern Gangetic Plains, are demonstrated to reduce water, energy, emissions, and labour, and increase profitability. And so I like to think of that as a demonstration of managing a nexus kind of at the farm level. As a result of that work, 120,000 farmers are now using these farming techniques in the Eastern Gangetic Plains. The cumulative impact is an additional 100 million Australian dollars in farm household income. So it's more than 5 times the amount that was invested in the program. And the program is literally just coming to an end in the next couple of months. There's also been 60,000 tonnes of CO2 mitigated and 60,000 megalitres of water saved. And importantly, there's positive benefits for women in households using those techniques. Another important element is that those practices have now been integrated into state government programs and policies in West Bengal, one of the states we work in, and they'll continue to scale without project support. An example of the impact of integrated research into sustainable groundwater development. So I think the focus on the nexus is really important in a groundwater dependent region like the Eastern Gangetic Plains. So although groundwater is physically available in that region, unlike a lot of parts of South Asia, it is expensive for farmers because they rely on water markets where they pay pump owners to use the service. And energy sources obviously matter because when groundwater is used, you need energy to pump it. So when diesel is used, it's much more expensive than electricity. And each state in India has its own subsidies for electricity. So farmers in Bihar, which is in the northeast, pay about 30 times more compared to farmers in the Punjab to pump water. But West Bengal and Bihar are changing their energy policies to increase rural electrification so that farmers can have better access to water. So one of the studies looked at the impacts over the past decade in West Bengal, where water energy policies had changed about 10 to 15 years ago. And they found that although the number of electric pumps increased, farmers didn't change their cropping patterns or increase productivity. And that's unusual. It's unlike what's happened previously in other parts of South Asia. Farmers told us it was because other input prices had also increased and output prices had stayed the same. So profitability declined and there was little incentive to increase production. So another small project also looked at the impact of what affected farm profitability and found that the biggest impact was output prices, so even compared to fertiliser or energy prices. So I think, and there have been other studies, there are 3 or 4 or 5 studies actually that look at different elements of the groundwater, energy groundwater nexus, food nexus. And having that suite of studies can show how the close interaction of energy, water and, well, it shows the close interaction between those energy, water and food policies and the importance of research that works at the nexus. And a range of different projects looking at different levels can demonstrate reinforcing messages and identify robust recommendations to help groundwater be developed sustainably. In terms of benefits for Australia, research for development lets us showcase Australia's expertise in agriculture and water management. As I said, the current program I work on is jointly funded by DFAT and ACR, and our colleagues at DFAT Post have been really appreciative of ACR work because it's practical and it gives something very tangible to see on the ground. And the photos here are 2 of the heads of mission, one in India, one in Bangladesh, in the field. So obviously there's good opportunities for public diplomacy. In terms of my tips for how to get involved, and I think some of these reinforce what Di said, seek out opportunities and make your intentions clear. I think people are often really willing to help the next, a lot of people coming through if you genuinely demonstrate that you want to follow this career path. Make and maintain connections, say yes to lots of different things, be patient, and I think Diane Lee would agree that if you're not already patient, you will have plenty of opportunities to practice that. And finally, be willing to do things outside your remit and your comfort zone. So I would say I've done everything from lug fertiliser bags to seemingly pointless administration to meeting ministers of agriculture to help design and facilitate a clown show, which is the photo here. So that was a clown show in the south of Laos to communicate results from some of our project work. Yeah, so in short, a lot of stuff that's never been in any job description or any subject I studied at uni. But I've also thought more times than I can count that I can't believe I get paid to do this, and it's such a privilege. So I think if you want to be reminded of your privilege and then also given an opportunity to work with others to do something about it, then I really highly recommend this as a career path. Back to you, Cathy.
Terrific. Okay, just a minute. I need to unmute myself. I'm unmuted, aren't I? Everyone can hear me? Brody, that's very good. Okay, we've got a couple of questions that have come through. Not as many as I would have liked. So we've obviously done a very good job at explaining the work because there haven't been too many questions come through. We have one from So Kling, and I apologise if I've mispronounced your name. And I think what the question means is how difficult does the working with different local cultures make the work that you do? So how complicated does it get because you are working in different cultures? We might start with you, Di, because you've been quiet for the longest.
Yeah, sure. I guess local cultures affect things in 2 different ways, and one is how we work with local project teams on projects, and one is about the design of research. So in terms of local project teams, I think one of the things that struck me most working with my colleagues in some other countries is that the borders between work and family are a lot more blurry in some places. So for example, with my colleagues at the University of Veterinary Science in Myanmar, it's really common to have people's wives and their kids coming into the lab during the day and being part of that whole research experience. And we tend to communicate more using social media, Facebook, Messenger, Viber, WhatsApp, rather than in Australia where we tend to focus on more traditional mediums like email and phone calls. And then in terms of designing research, I think it's about understanding some of the different reasons, and they may be cultural, about why farmers do what they do. And so a great example is a research project we had in Tibet looking at dairy systems. So we know that farmers keep dairy cows to produce milk, but you need to think about why are they producing milk, and how are they getting paid for that? So in Tibet, they use milk to produce milk butter tea or cheese. And so you want milk with a really high fat content, as well as having good yields. And there are differences between different breeds of cattle. If you have a Jersey cow, it's got really high fat content, and so it's a lot more appropriate to have in those systems compared to something like a Holstein cow, which has slightly higher yields, but isn't going to produce the right sort of milk that suits the reason that people are producing milk for.
Okay, thanks. And I imagine the different countries that you all have been working in, even, you know, different countries in the same region, Tamara, I expect that actually brings up some interesting, I guess, levels of complexity when you're trying to work on the same project with the same sorts of technologies, for example, but doing so within different cultures. Do you want to comment on that?
Yeah, definitely. So the Eastern Gangetic Plains is obviously one kind of contiguous land area. And, you know, on a map, it looks like a pretty small area. And but the differences between the countries are quite stark. It can be cultural, but it can also be as a result of different policy settings and kind of development trajectories, I guess. So I think there's quite stark differences between Nepal, India and Bangladesh. And even within India, because we work in the northeast, it's quite different to the northwest. So I think, yeah, there's lots of influencing factors, so cultural, but also policy and development settings.
And I guess, Lee, for you, you're often working a lot more at the, and I could be wrong, but at that very sort of laboratory angle of the research. I'm sure you get into the field as well. So what are your comments within the different cultural complexities, even within a laboratory, for example?
Yeah, I think it's I think in the field of science in general, there's a lot of challenges, and those challenges are actually overlapping between Australia and these other countries, and particularly if we think about the hierarchical structure of, you know, academic institutes or some of these different institutes we work with as well. There's challenges there, just like we have here in Australia. And one of the key challenges for us around breeding technologies, and you're trying to introduce something new, it's a change. And that's very difficult when people have done something a certain way for a long period of time. And, you know, I think that's probably one of the biggest challenges we face. And so to get around that, or to help accommodate that, we get back to the science. We talk about, you know, resources in the breeding programs. How can they be better utilizing resources? What's the savings in costs and resources, and you know, jobs that that's a lot of the things in these programs. They employ a lot of people, and which is fantastic. A lot of people in the field that would normally be growing these plant populations. It's not about cutting their jobs. It's about reutilizing them and maybe teaching them new skills to basically get them working in different parts of the breeding program as technology and methodologies change to become more efficient. So yeah, a lot of challenges around this, I suppose.
Cool. Okay, there's a question here for you, Di. How do you see the light? This is from Jess, and Jess is a member of the Research in Agriculture for International Development Network. I just had to get that in, everyone. So Jess wants to know, how do you see the livestock sector getting to carbon neutrality? How are developing countries going along in that area?
Thanks, Jess. I guess it's the multi-million-dollar question. The research that we originally did in this area, we started off by trying to to break down the different emissions from the livestock sector. You know, what emissions come from animals, either directly as methane or indirectly through manure as it gets decomposed, and then the land sector, so grasslands, production of crops, deforestation has emissions. And so break them down to work out where the opportunities were at the national scale. And so MLA have used that to inform their goal for the red meat industry. I guess as we move along, one of the challenges is understanding the diversity of production systems within Australia. So just like there are differences between Indonesia and North Queensland, there are huge differences between North Queensland and Victoria. So we've got some really exciting things starting to happen. In the last year or two, there are some feed additives which are starting to become commercially available, which can decrease enteric methane. So that's the methane from the cow, which is responsible for most emissions. They can decrease that by in the range of 40 to 80%. If you're in a feedlot situation or the more intensive farming situations in southern Australia, and also some developing countries, it's quite easy to get these feed supplements out to cattle if you see your animals every day and you control what they eat. So there's some big opportunities there. I think the real challenge is for more extensive production systems like Northern Australia, large areas of Africa where we have pastoral systems. People don't see their cattle every day. They're grazing whatever's available, so you don't have much control over what they eat. And so we're having to push science a little bit more to work out how can we get those additives into animals? Is it through a slow release implant or something we put in their stomach? Perhaps it's vaccines or genetics are a better solution, but they're a little bit of a longer term solution. So I think, you know, there's no easy answer. It's going to be really hard. But there is globally, there's lots of research happening, and there are people looking at specific things that can be applied in a diversity of systems, both in developing and developed countries.
Okay, it is a really exciting area of research. I know I'm up here on the Sunshine Coast in Queensland, Australia, and one of the local universities here is doing a lot of work around seaweeds. And the impact that can have on reducing greenhouse gas emissions. So it's exciting that there's so much work going on. There's a question here for you, Lee. When you showed the chart with the projections for output of wheat and then meeting the population needs for 2050, how much is an issue going to be around the availability of phosphate and soil nutrients?
Yeah, well, I guess that's also an important consideration. You know, the fact that a lot of our land is also degrading. We need to become more efficient from, you know, in terms of producing food crops from a smaller area over time. You know, and inputs will become more and more important. You know, obviously some of those fertilizers require a lot of energy, and greenhouse gases are associated with producing some of those things. So, you know, I think one of the big goals around plant breeding and crop improvement that a lot of researchers are working on is trying to make crops more efficient in terms of the nutrients that they're using. So it's not just about drought tolerance and heat tolerance, also using less fertilizer as well to produce, you know, equivalent yields or equivalent quality for some of these food crops. They're important goals as well in a lot of breeding programs.
Okay, and just so that Tamara doesn't feel left out, we have a quick question on water saving technology, and otherwise I think we might have one more question after that because we're running out of time. The question is from Than, saying if water saving technology is applied in crop production, what's the impact of that on yield? What are the pros and cons between you know, making those saving technologies and just what's being done now?
Yeah, so I can only speak about the conservation agriculture techniques in the Eastern Gangetic Plains, but the trials that were done over several years showed on average yields actually didn't decline, so there was even a slight increase in yields, but obviously that depended on location and technology, individual technology, machine, for example, or different crops, but overall there was no yield penalty. So I guess that wasn't an issue, but people did also, the savings in input costs also even, you know, still kind of offset some of that. Even if there is a reduced yield, still, you know, are appealing to farmers because they are still reducing input costs. And definitely the big factor is labour, like reducing labour costs as well. That's very appealing to farmers in that location.
Terrific. I'm being given the wind up, I think, aren't I, Tianyi? There are 2 more questions I know that we haven't got to. And in fact, the panel might like to go to the Q&A. One is for a general question. We might be able to sneak this one in. I'll at least ask one of you. Paul's asked what's the biggest challenge of your international careers? What advice would you have for young people looking to pursue similar careers where there's frequent travel and time away from families? Maybe Tamara, since you were traveling with, obviously with a family, that might be a good one for you.
Yep, I'm happy to answer that. The first thing, I think one of the challenges is has been short-term contracts. So I think, you know, again, in hindsight, I have never been unemployed, but there's, you know, there's periods where it's coming, you know, the contracts are coming to an end and you're not sure if it's getting extended or it's kind of, that's getting close. So that can be a source of stress, and it depends what kind of person you are, whether that's kind of a pressure you want to take on. In terms of, yeah, traveling, to be quite honest, I've been overseas with my family, you know, since my oldest child was 1, and my husband has been very supportive. So he has been the primary caregiver, and obviously overseas you can get a lot of help. You can employ people to kind of fill gaps where you don't have family. So I have found coming back to Australia to be quite the challenge, really, because suddenly we're 2 people working with kids at school and no family around to help. So yeah, for me, basically taking my family overseas was the answer to that, to the challenge of travel. Yeah, so if anyone's got tips for me living in Australia, that's what I'm interested in hearing.
Coming back. Okay, so look, thanks so much. As I mentioned before, there is 1 or 2 questions in the chat room, sorry, the Q&A room that you might want to have a look at, panelists. Otherwise, I think we're being given the wind up. Before we close, I just want to give a plug to Reade again. So Reade membership is free, and it gives lots of news about what's happening and opportunities for these sorts of webinars, as well as PhD opportunities and a whole range of things. So please have a look at Reade, Researchers in Agriculture for International Development Network. It's free and they're wonderful people. The other one is to plug the Crawford Fund Conference, which we hope is coming up in August. And there's some really great discounts for students, and it's free online for people in developing countries. So that might be of interest. It's around biosecurity, health and trade. Talk about nexus issues tomorrow. There's a few more. So the other one, last thing for me to do in the last 10 seconds is to thank our speakers, but also especially thank our audience. And again, to say how great it is to be able to interact here with the RDI network, which is a new find for me, which is great. And also to thank UQ for their involvement. And again, behind the scenes here, Adam Wood, who has been doing the technical side of all of this. Thank you very much. And I'm not quite sure now if I close off or if somebody jumps in. It looks like I'm closing off, I think.
Yeah, and we can end from here as well. Thank you, everyone.
Okay, thanks everybody. Thank you.